Hello all. In this video, we are going to build a decentralized note-taking app on Solana blockchain platform. This is going to be a full-stack Web3 application. We are going to build a front-end using Next.js with TypeScript and Tailwind CSS and deploy it on Vercel. And backend is going to be on Solana blockchain using Rust programming and Anchor framework. And we'll deploy it on Solana Devnet. Before we head to the actual development, I want you to install the Phantom Wallet on your web browsers. Open Chrome Web Store, search for Phantom Wallet. Once installed, create an account. I have already created accounts. So once you have created the account, go to the settings, go to the developer settings and enable this testnet mode. Because we're gonna build this program on the Solana Devnet, it requires us to enable this testnet mode. Done. Now let's start the actual development. So we'll be developing our Solana program on this Solana Playground. It's a web interface where we can write our Solana program, build it and deploy it and test it. So we'll build our program here. No need to install anything in our systems. Head over to beta.solpg.io. You'll see this interface. Now let's create a project. Click on this add icon and name the project as Notes Dap. We'll select the Anchor framework. We're going to use the Anchor framework. Create. Now it creates a project for us. You can see the file tree. We have a source directory with a lib.rs file. This is going to be the main file for our program. I'll remove the entire code in this. We'll keep these two lines and I'll explain them why. Since we are going to use the Anchor framework, we'll import that. So in Rust, use means it's like import. We'll be importing anchor lang, prelude, and all the functions or utilities that are available in prelude. We'll be importing all those. Done. Now what is this? This is called macro in Rust programming. You can see this is your program's public key and it will be updated automatically when you build the project. Since we are going to build a Solana program, on Solana, each and every program will have a unique public key. We'll be identifying a program with its public key. So on Solana Playground, it will automatically provide a public key for us once we run this build. This is to specify the public ID of this program. Now let's start the actual development. So in case of a full stack application, we'll be having backend, frontend, and database, right? Here also on Solana, we'll be storing our data on the Solana blockchain. In case of Solana, each and every data that we store will be stored as an account. We call them as program derived accounts. We'll learn about program derived accounts more, but on Solana, whatever the data we store will be stored as an account. Okay, now let's start. So here I'll write a macro. In Rust we call this as a macro. So what this specifies is, this specifies to the Rust program that the main program for this is going to be here. We'll say public, we'll create a module, we'll call it as notes app. So whatever the core logic is there, we'll be writing the core logic in this. Okay. In case of a Web2 application, we'll be writing the API handlers, right? For each and every API, we'll be having API handlers. So all those API handlers will be writing in this. In this module, we'll be writing the handlers, all the handlers. In case of our note taking application, we'll be having create note, we'll be having update note and delete note. These are the three handlers. We'll write those handlers logic in this module. we'll write the handler functions. Done. Now for any full stack application, we'll be having front end, back end, and database. On Solana, we'll store the data as an account. Each and every data that we store on a blockchain will be having an account. So first, let's define the schema of our data for our nodes application. Since the data will be stored as an account, we'll specify this macro. We'll specify this macro as account. Now I'll define a struct. I'll define a struct called node. Think of this like a schema of our data. Schema of our data for our node taking application. So I'll take author. All these are the fields. All these are the fields. So here author is the person who is going to create the node. In case of Web2 application, we might take the author name, right? When it comes to a Web3 application, we'll be having a unique ID for that author. We call it as a pub key. We call it as a public key. Now we'll be having a title for our nodes. Title, it's of type string. Done. And the content of the nodes, it's also of type string. Now we'll be also storing the timestamp when it is created. And the type is int 64. This is signed int 64. It is a 64-bit signed integer, positive or negative. It's a 64-bit one. Since we're going to store the Unix timestamp, we're going to take it as int 64 because Unix timestamp will be in integer format. Next, last updated. If we update our nodes, we'll also store the last updated timestamp also. This is also a Unix timestamp, same int 64. Done. Now this is the structure or the schema of our data which we store on Solana blockchain. We also have to specify the length for the title, the data length for the title and content. So here, how can we specify that is, we'll say max length 100 for the title, and for content max length is 1000 characters. Done. And for created it's in 64 and last updated in 64. So we know the size of that automatically. For title and content, we are specifying the number of characters, so it will know the size. And now this is the schema. Let us define the handlers. I'll define the empty handlers for now without the logic. So I'll create the handler functions. Public function create node. I'll explain what is this result. So for each handler, the return type is going to be of type result. So if you see, result is a type that represents either success or failure. So after this handler function completes its logic, it will return an error or a success response, which is of type result. Done. I'll copy this. The next one is update node, and the next one is delete node. Done. We have the handlers. We'll write the logic also, and we have the schema. Think of it like a database schema for our backend. Done. Now the next thing is, one more thing which we have to specify is, for each and every handler function, we need to specify the format of the request. Think like a Web2 API. For Web2 API, we'll be sending some data to the request, and the request will be having some format, right? Similarly, here also we need to specify the format of the request, the format of the request, the format of the data that this handler function takes. So to define that format, again, we'll create a struct and define that. So for defining that, we'll say, so what this specifies is that, okay, I'll write it and explain. Struct create node. Think of this like a request format, and this tick and info. This a core concept of Rust. We call this as a lifetime. No need to worry about this lifetimes. Now, what this specifies is that for this particular handler, the Rust program needs a request type, right? So here we will provide the request type as create node. So Rust program will check this macro, derive accounts macro, and it'll take the request format from here. That is why we need to specify the derive accounts. Done. Now again we need one for update note, derive accounts, public struct update note. Again we need to specify the lifetime. Done. And one for delete, public struct delete note. So here in this we need to specify the format of the request that this handler function is going to take. Now for create note. So while creating the note, what's the data that will send? One data is the entire notes, the title, the content, and everything will send into a request, and we'll also send who is the person sending that request for authentication purpose, right? Now, so here we will take the note, and the type is going to be account. Since the data is stored as account on Solana blockchain, type for this is going to be an account, and we'll specify the lifetime. This is a generic. So here the account type is note. This one, account type is note. Done. Now, whenever we try to call this handler function, first what happens on Solana blockchain is it creates a space for us. It creates a space for us to store the data of this note. So in order to provide that instruction, we need to do this. So we need to add this macro. So let us say we are creating our note for the first time. Creating a note, whenever I create a new note, that is for the first time, right? New note is for the first time. For the first time, Solana blockchain need to allocate some memory, right? So it means we are initializing some space for that. And since we are consuming some space on the blockchain, we need to pay some rent. So we need to specify the payer, the person, the account from which the rent gets paid. So it's going to be the author, and we also need to provide the space. Here, space is 8 bytes. Why 8 bytes is? I'll explain. Here, the type of this account is note. So while storing the data, we'll store it as an account, right? So in order to create a public key for that account, what this Solana program does is these 8 bytes are for specifying that it is of note. Account type is note. It says the account type is note. This will take 8 bytes of space. Think like that. It will take 8 bytes of space. Now this to specify. Now what is the space that is consumed by the actual data? This is the actual data, right? So this data will also consume some space, right? So in order to calculate that space, we can do one thing. So I'll add a macro here. I'll add a macro. Let's say derive init space. So if I add this macro, I can directly calculate the space. So I'll say note the name of this struct, and I'll say init underscore space. If we use this syntax, what it does is it will calculate the space this particular struct will consume, because we have already provided the length for title, length for content, and int64 means we already know how much space it takes, and popkey also we know how much space it takes. So it'll calculate the space and provide us. So 8 bytes for this account colon note. We call it as discriminator. And then the actual data. So for each and every account, we'll definitely provide this 8 bytes for the discriminator, that is the account discriminator. Now we are saying that we'll be having a unique account for the data, right? So that account needs to have a public key, right? So in order to generate that public key, it should be unique, right? So we need to specify what are the parameters we are going to use to generate. Let us say, think of a web application. We have a database, we have ID, or we have a first name and last name. We create keys, right? We combine several columns. I'll combine name column, and I'll combine mobile number column, and I'll consider it as a one key, right? Here also we need to specify several parameters so that we can create a unique key, unique public key. So I'll take note a string in bytes format, and then this note is created by a person, a author. I'll take the author's public key in bytes format, and I'll pass the reference. Here we need to pass the reference to this seeds array. We need to pass the reference. I'll pass it as a reference. Then whenever we call author dot key, we'll get the pub key of that author in bytes format. When we say dot as ref, we'll get the reference of that pub key in bytes. Then now author is creating. So if we store just note plus the author public key, we can form one key. Whenever author tries to create a new note, we cannot use the same key, right? If we use the key, we can only create one note. So in order to create multiple notes, we'll also take the title. We'll also take the title of the notes for creating our unique key. We'll consider the title also. Next, we'll say bump. Why this bump means, since we are creating a public key here, we will create a key for the data or account. So we have to generate that public key. So we have to generate a valid public key. Maybe the data which we provided might not generate a valid public key. So in that case, whenever we provide this bump, what Solana program does is it'll start from 255 to 0, and it'll take each value and try creating the public key. Whenever a valid public key is created, it will consider that as a key. So we need to provide bump so that we get a valid public key, because we cannot guarantee that this particular data can create a valid key. Okay, if we provide bump, then it will try some random values. Think of it like a salt. Let's try some random values until we get a valid key. But the values are not random. There are some specific values which it uses, okay, until we get a valid key. Done. So this is the macro that we are providing for account, that is note. Now we'll also get the person who is creating a note in this request. This is a request for our handler. So it's going to be the author of the note. Since this is going to be a write request, because we are creating something, it's going to write something on the blockchain. It means the person needs to be a valid person and he needs to be a owner of that data. So he will sign the data, he'll sign the transaction. He's the signer. We need to say signer, and again the lifetime is info, is the signer. Now here again we need to provide one more macro, that is account and mutable. Why mutable? Mut means here in Rust it's mutable. So by default all the variables in Rust are immutable. If we want to make it mutable, definitely we need to provide it as mutable. Here why are we providing account macro with mutable? Because since it is going to create some space on the blockchain which requires some amount, it requires some fees, right? That fees will be deducted from the author's account. It means the balance of the author's account is gonna change. Since it's gonna change, we need to provide mutable because it's gonna change. Done. Now we'll provide a system program. I'll explain it why. The lifetime is info system. Why system program is, for creating an account we would need some other programs. In Solana we need to specify everything explicitly. It will not use the other programs directly. So we'll use some other program in our program to create the account. Use the existing program to create the account. Done. So this is the request for creating a note. This is a request for creating a note. Now let us try to write the handler function also. Let's try to write the handler function for this create note. Here. Now for the handler function we'll receive the request, right? Receive the request. The request we'll call it as context. We'll get the request as context. The type of that context is going to be this create note. And the arguments which we'll get are the title and the content type string. Now the flow is, whenever we try to call this handler, first this instruction gets executed. So temporarily it'll create some space. It'll create some space for us on blockchain. Think of it on a RAM. On a RAM, it'll create some memory space for us. Empty space. You're not providing the data yet, the title and content. It'll create an empty space, and this instruction will provide the context, the reference to that space. We will directly receive the reference to that empty space. Okay, we got the reference to that empty space. Now what I'll do is, I'll take the reference, I'll take the note. We'll get the note, right? I'll take the note. Since we're going to change that, right now it is empty. We need to put this data, the title and content. So I'll take the reference as mutable. We're going to change it. So to get the data, we'll say context dot accounts dot note. We'll get this one. And now we need to set this. I'll save it. Done. Now I'll take the time. Okay, I'll take a variable clock. So to get the time, call this and question mark. So why question mark means what it specifies to the Rust compiler is if this gets failed or if we get some error, immediately return that error. We specify a question mark, it will immediately return that error to us. That's why we specify a question mark. Now let's make some validations. Title should not be more than 100 characters, right? So we'll use this require, and here we'll specify our conditions. Title dot length should be less than or equal to 100 characters. If it is not, then we will return an error. So we haven't defined the errors. Let me define the errors here. So for defining the errors, we will use the error code macro. We'll specify the error codes in this macro. We'll create an enum, call it as nodes error. So now I'll create the errors. Message, say title cannot be longer than 100 cars. Title cannot be longer than 100 cars. This is the message, the error message, and the key. Think of the title of that error message is title too long. Okay, done. So how we use that is we'll say nodes error title too long. Done. If we provide this, then it'll automatically, when condition gets failed, this error gets returned. Done. Require, it says unresolved macro. Okay, let me check. Okay, it says unresolved macro. We missed something, that is here we are trying to import the anchor frameworks utilities and the functions and interfaces, but since we are creating a module and we are writing the handler functions within that module, we cannot directly access them. So in order to access them, we need to do this. When I say this, use super. So whatever the imports that are outside this will be available in our module. Done. So now the error is gone. This is one condition, and the next validation is we need to validate the content also. Sorry, content dot length should be less than or equal to 1000. If not, then again we need to show an error. We'll say message content cannot be longer than 1000 chars, and I'll name the error as content too long. Done. Notes error content too long. We're done with validating the content, and now, and we should also make sure that the title and content are not empty. Title and content are not empty. How can we validate that? We'll say title. I'll trim the title. And I'll check if it is empty. Is empty. We want it to be not empty. So we want it to be not empty. Then If in case it is empty, we'll show an error. Message title cannot be empty, and the error name is title empty. Title empty. We'll also create error for content. Content cannot be empty. Content empty. Done. If the title is empty, we'll return notes error title empty. Done. Next, I'll copy this. I'll take content. I'll trim it. Content empty. I'll return this error. Okay. So if any of this validation gets failed, we'll not be able to create a note. We'll get this error returned. Done. Now our validation is done. We all know that whenever we try to create a note, we will get the reference. We will get the reference. We're taking the reference to that note, which is right now it is temporarily available on the Solana blockchain. Now we can directly add the data to that reference. We'll say note dot author. Author is the person who owns the note. We can get that from accounts dot author dot key. We'll take the public key of the author, and the title is, we'll get that from the argument. So since that the string, I'll just clone it. Done. Next, note dot content. Content again, I'll clone it. Done. So here we are directly updating the data to the reference on the blockchain. Again, no need to do anything. Once we say node.author equals to this one, the data will directly get written on the reference, the temporary space which is created. Now, node dot created it. This is the Unix timestamp, right? So we have clock here. We'll say clock dot Unix timestamp. Done. It is created it and initially updated it. The last updated will also be the same, the Unix timestamp. Done. We have inserted the data. Done. Now when we say this, okay, this is same as return. This is same as this. In Rust, if you don't specify a semicolon, think of it like return. So here we are returning a success response. I'll also log something. So in order to log, we can use this. So we can see these logs on the Solana Explorer logs. I'll show that. I'll say note created, and let's show the title also. Title author created it. Done. I'll provide them. So the first one is title. We know the title. Then node dot author. Then node dot created it. Okay, I'll take node dot title. Created it. Done. We are logging the message when we try to create a note. This is for creating a note. Now we need to write the request format for update note also. Let's write that. For update note also, we'll get the note, right? We'll get the same data. So I'll take public note. It's an account, right? It's an account. Lifetime is info. Type is note. It's a generic. generic, and the type is going to be note. So again, we need to specify the macro. Here, when we try to update a node, it's an existing account. It means it's an existing note. It's an existing note. Now, since it's an existing one, no need to write init, just like we did in note create note. So no need to write init. Since we are updating it, we are trying to change that, we need to provide the mutable. Then the seeds, because we need the pub key, right? For updating the note, we need the address of that account, right? Public key. So for that, again, we need to derive that. How can we derive? Same author dot e as ref and title dot as bytes. Done. Here it is node dot title, sorry, it's node dot title, as bytes. Done. Now the person who is updating is the author, right? Is the signer, is the one who will say that I wrote the data, I'm validating it. So he's the owner, he will sign that transaction. Done. The author. Again, since we are trying to extract the pub key, again we need to provide the bump. We'll try to get the valid public key. Okay, this is not random. Again, we'll try a sequence of values. Whenever it hits a valid public key, it'll stop. So the bump here and the bump here will be the same, because it'll take same sequence of values for creating the public key. And now here I missed something, that is, here we're trying to use title.asBytes, but if you see in this, we don't have the title directly. So we cannot access that directly here. So in order to access that, we need to provide an instruction that we will be using this title from this handler. So we need to specify that title of type string. Okay, but when it comes to update, we already have the title, right? We already have the title. Done. We already have the title. That's why we need to provide. We'll take it from the note. That one I missed it here. Done. So this is for update note. This is the request format. Think of it like a request format. Now let us write the handler for update note. So the handler for update note will be taking the inputs. So for the update note, we'll just be able to update the content. We will not change the title. We'll change the content. We'll get the context of type update note. We will get the content type string. Done. Now again, I'll get a note, right? Same like we did it here. I'll get a note. We'll take note equals to, since we are updating, I'll make it as mutable, because we're changing it. Just we need to specify. By default it's immutable. We need to specify if we are going to change it. Now context dot accounts dot note, I got the reference. Done. Now I'll take the clock for the timestamp, because we'll provide it for last updated. Get question mark. Done. Now again, here we will only make the author who created the note, will only allow him to update the content, will not allow others. So we'll add one validation, that is, we'll get the node dot author. Here node dot author, that is this one, the person who is trying to update. Here this person may be the original author, may be the someone, right? But we should only allow the original author, right? Here node.author will check accounts.author.key. Will check whether the person who is trying to update is the original author or not. Okay, here this is the original author. This is the author who is signing this transaction, that is making this update node transaction. Now again we'll send an error message. Let's write that. We'll say message unauthorized. Okay, here we'll say nodes error unauthorized. Done. Validated. Now again we need to make sure that the content is again not more than 1000 characters. I'll take the same line from here, I'll add it here. Done. Again one more validation is we don't want the content to be empty. I'll update it again, the same value. Done. Now after all the validations we can update the content. So here what we'll get is we'll get the reference. So now whenever we created a node, initially it have allocated some space temporarily. Then once we created it, the data got stored on the blockchain permanently. Now whenever we try to update it in the instructions, in this instruction, we are trying to get the actual node. Means we'll take the author key, we'll take the title, and we'll take the exact node, the exact account. It means we'll get the direct reference to that account on the blockchain. Now again we can directly update node dot content equals the content. Done. We update the content. Now last updated node dot last updated is again clock dot Unix timestamp. Done. So and okay, return the success response. Here let's log it again. Message node, I'll show the node title updated. Done. Show node dot title. We'll already have the node dot title in that, so we'll show that. Now this is how we update the node. Cool. Now the remaining thing is delete node instruction and the handler, the request format and the handler. Let's write the request format for delete node. It's almost same as the request format for the update node. Let's write it. Okay, let me take the inputs. Public node, get the node info, type is node. Here we need to provide the macro account. Again, since we are going to delete, it's a change, right? It's a change. So again we need to provide mutable, and we should be able to extract the account public key, right? So again we need to provide the seeds. We'll get the bytes for note, then author dot key dot as ref. Done. Next we'll get the title as bytes. Done. And bump. Okay, whenever we try to create a seeds, then provide the bump so that we get a valid public key. Done. Now since we are gonna delete this account, we need to specify close. And so whenever we store data on blockchain, we are paying some rent. Let us say we don't want to store it on blockchain, so we are deleting it. Let's say we paid the rent for 1 year and we are deleting the data just after 1 month. So we need to get back all the rent, right? So close, and I'll provide the author. So whenever we provide close, it will close that, it will delete that, and whatever the extra rent that we have paid will be refunded to the author account. Will be refunded to the author account. Now author, the person who is going to delete, is the signer. Is the signer and the owner. And one more thing. So here we have discussed that whenever we're trying to create, the author's balance get changed, account balance gets changed. That's why we provide mutable. Here also the author's balance get changed because we will get the amount back, right? Since the balance is getting changed, we need to provide the account macro with mutable because the balance is gonna change. Done. This is the instruction for delete note, the request format. Now let's write the handler for the delete note. So again, same here, we are going to take the context. We are going to take the context, that is context delete note. Done. Let note equal to mutable. Oh, here we are directly deleting that, right? So I don't take mutable. Done. We just take the reference, that's it, nothing. We're not trying to change the note. Here we took the mutable because we are deleting that account. Okay, here we are not trying anything. This instruction itself will delete, but here we'll make some validations. So first validation is this one. We want the owner to delete, that is the author. We'll check whether the person who is trying to delete note is the owner. If not, unauthorized access. Then we'll just log a message. We'll say note deleted, not deleted. Let's see the title. Done. Done. We wrote the handler for delete note. So we are almost done. It means we're almost done with the handlers and the instructions and the DB schema. Now it's time for us to build it and deploy it. Okay. Now let's try to build it and check if there are any errors. Okay, it might take some time. Build successful. Now we'll deploy it. Okay. So if I click on deploy, the program gets deployed on the Solana blockchain. So if you are trying it for the first time, maybe your account might not have the enough Solana to deploy the contract. So it will ask you to airdrop some Solana. So to do that, click on deploy. If you get an error, obviously it will prompt you in the this CLI whether you want some Solana to be airdropped into your account. So to airdrop Solana airdrop, let's say 1. If I say this, we'll send 1 Solana to our accounts. Okay. Uh, Once you click on deploy, it will obviously ask you whether you want Solana if you don't have. Okay. Now it says success. The Solana need to be reflected in my wallet balance. Okay. Now let's click on deploy. It can also take some time. You can see the loader here. So once this is deployed, we can directly test our program within this interface only. So that's the speciality of Solana Playground. We can test it here itself. So it's confirming our deployment. So we can see deployment successful, and it shows a Solana Explorer link. Let's open this. So our program got deployed successfully. Okay, you can see program written success, program invoked. Okay, done. Now let's head back to Solana Playground and let's test our application. Okay, I'll head over to this test tab. Now here you can see the instructions. So interesting, right? We have created the instructions, the create node, update node, and delete node. So these are the request formats or the input formats for our handlers. So think of them like forms. They are the forms which we are going to fill to create a node. So here, so if you see, we have got a form. I'll just reset this. So here, see the inputs that we are providing are the title. Okay, let's go to the handler. The title, the content, and the note. We'll get that in the context. So title, let's provide some title. So here we need to select the type also. It'll ask you to select the type. Select the type as string, then select it as custom. So I'll say my note 1 and click on custom. Done. Now I'll say some content. This note is created on Solana Playground. This node is created on Solana Playground. It's a custom node. Click on custom. Done. Now here what is this? We need to provide the account address for our node. So the one node which we are going to create will be having an account on the Solana blockchain. It needs a public key. So if you see this create node, we are trying to generate a public key, right? How are we trying to generate? We're taking three parameters. One is a string, that is node, we'll convert it to bytes. Again, the author public key in bytes, title in bytes, right? So here also, since we are taking seeds, click on from seeds. The first seed is node. Select the type as string. The seed is node, type node, click on custom, it gets added. And the next seed is the key of the author, that is public key. So click on public key. Since I am the author, click on current valid. Done. Second seed is added, and one more seed is the title. Title is my note. I'll copy this. Again, it's of type string. I'll paste it. Custom. Done. Click on generate. If you see, it have generated some public key. It have generated a public key. So it will be the public key for the data account which we're gonna store on the Solana. Next, the author. Since I am the author, I'll click on current wallet and system program. No need to touch it. Let it be default. Now I'll click on test. I'll open this. I'll clear this. Okay, I don't know why this is not working. I'll open this again. Okay, it got stuck. Okay, let me click on test. So you can see test node passed. We can see the Solana Explorer link. I'll click on it. Now let's see the logs. So these are the logs. If you see program log, node created, title my node 1, author, the author public key, and created it, the Unix timestamp, right? So here if you see in create node, we have logged it, right? So we can see the logs. Here. We have successfully created a node. Now let's try to get that node. So click on, since it is an account, right? It's a program derived account. So we can fetch that. So how to fetch that? In this account section, open this, click on fetch all. So if you see, this is the data. This is the node which we created. We have the author, title, content, created it, last updated it, right? Interesting. So we have created a node and we have tried to view that node. Now let's create one more node. Okay, I'll take my node to custom type this. Okay, I'll name it something different. This is a second node from Sol PG custom. Again, here we need to generate a public key. Click on this, again click on seeds. We need to edit one value, that is this title. Then okay, I'll show that. This one, note the seed note string, it's the same. The author, it's me, it's the same. And the title I'm changing it as my note 2, the custom one. Click on generate. uh, don't worry about creating the seeds. When we create the front end application, we'll be taking care of it in the front end itself, in the logic. User will not create the seeds manually. Okay, will not ask the user to create. We'll handle that in the logic. So since we are testing it on the Solana playground, we are supposed to provide. Okay, now again I'll click on test. You can see create node passed. Again I'll fetch all. We should see two nodes. So you can see my node 1 and my node 2. Okay, we can even fetch a node by public key. Let me take this. There is a public key of this node. I'll copy this. I'll paste it. When I click on fetch, you should get that one. So we got the one, right? I'll again fetch all. Clear this. Now what I'll do is, let's test the update node. So update node. So I'll reset it. Update node. We need to provide the content. I will try to update my first node. It is written as this node is created on Sol PG. So I'll say this is an updated node from Sol PG. This is an updated node. It's a custom string. Done. Now we need to specify. Let's go to the update node. Here again the seeds. From seed, first string, that is node custom one. Add one more seed, that is for author. It's me, the public key of my current wallet. Done. Again add one more seed, that is the title of the node, the string. The title of the first node is my node 1. I'll copy this and I'll paste it here. Done. Click on generate. So if you see, it'll generate a public key. Let's see whether it is same as this one. So if you see, it has generated the same public key. We can either generate it from the seeds or we can directly copy this. Okay, just to explain, I'm generating that because we already have the public key. We can copy this and paste it. It's the same. Okay, now author, it's the me, the owner. I'll select the current wallet. Let's test it. Again update node passed. Now we should see the updated node. Here it is. This node is created on Sol PG. Again I'll try to fetch all. Now we can see this is an updated node from Sol PG. It means we have just updated our existing node. Done. Now let's try to test the delete node. So I'll delete this one, the second node. So here, what are the inputs? Okay, I'll reset this. Inputs is the public key, the account address of the node. That is this one. I'll directly copy this instead of generating it from the seeds. I'll copy this, paste it. Author, it's the me. So current wallet. Click on test. He just deleted the node successfully. Let's try to fetch all. Now the node 2 got deleted. So this is how we write a program and build it, deploy it, and test it. So whatever the tests which we did now are on the Solana Devnet, not on the mainnet. The Devnet, which is for development purpose. So again, let's quickly revise how to write a program. First, we need to define the structure of our data. Done. Then we need to create a module specifying the macro. Clear. We'll import everything that is available outside. Done. We'll create the handler functions. Now for each and every handler function, we need to specify the format of the request, or we call it as an instruction in a struct. So for them also we need to provide this derive accounts macro, and if we are trying to use some value which is an argument, we need to specify it as an instruction. Done. We'll be providing the instructions. Done. And we'll write the logic. For error messages, we'll specify error code macro and define the errors. So till this, we have just created a program, build it and deployed it. Now the next thing is we have to integrate it with the front end. Here we are filling the form, right? Now we need to create an interface where a user can connect his wallet, and then he can create the nodes, update the nodes and delete the nodes. Now let us start the front end part of our application. We have our Solana program deployed on the Solana Devnet. We have our program ID. Before we start the front-end development, make sure you have the Phantom Wallet installed. I've already mentioned it at the start of the video. Now, before we start the front-end, let's download a file. Go to this build and deploy. Here you can find ideal. We have to download this ideal.json file. If you have worked on Ethereum Solidity, we'll be having ABI file. So this is ideal on Solana. We'll download this, click on export, download that ideal.json and keep it handy. We'll be using that in the front end part of our application. Okay, now let us create our Next.js application. Say npx create next app. I'll name it as notes app, and I'm using TypeScript, ESLint, Tailwind CSS. I'll take all the default options. It's creating the Next.js application. Yeah. Now let us cd into the notes app. I'll open this in VS Code. Yeah. Okay, we can see we have our source directory, app directory and page.tsx. Okay, let us start the app. npm run dev. Okay, let's open localhost 3000. Okay, now our Next.js app is initialized and it's running. Okay, let us remove all the code. We don't need this, so I'll remove it. Simply return an empty div. We don't need this. Done. Next, in layout.tsx. Okay, done. We need to install some dependencies for our application in order to connect with the wallet, and in order to interact with the Solana program, we need some packages. Let's install them. Okay, let the app be running. I'll open a new terminal. Okay, now I'll install. Okay, so we're going to use the project serum anchor and the Solana wallet adapter base from the Solana wallet adapter, and the React part. We're going to use some UI components like the wallet button and wallet selection models. For that, we're going to use the few packages which are provided by the Solana, and we are also using the Solana web3.js. Okay, let's install them. Now we have installed all the required packages. It will take some time. If it is taking more time, just try to cut it and install it again, then it'll be fine. Now we have all the packages installed for us, and we have our application up and running. Okay, I'll hide this. Now we need to make the wallet connection for our application. So what we are going to do is we have to wrap our entire application with a wallet provider, just like we do it for Redux, right? In case of Redux, we'll be wrapping our application in the provider. So here also we'll be having a wallet provider for the interaction with wallet. We are going to use the Phantom wallet and also the connection provider in order to interact with the Solana Devnet. Okay, we'll be wrapping our entire application with those providers. So let us create the wrapper. Okay, so I'll create a folder in src components. In this I'll create a provider called wallet context provider, and let us write this. Okay, this is going to take children because we're going to wrap this, right? So it'll take children. Type will be React Node. Done. Okay, I'll add children here. Children. Done. Now let's import some packages which we require. We are going to use add Solana wallet adapter base and add Solana wallet adapter React, Solana wallet adapter React UI provides us some UI components which we are going to use, and Solana wallet adapter wallets. It provides us the wallet, the Phantom wallet. Okay. Now again the Solana Web3.js. Solana Web3.js. Done. Cool. From Web3.js, we're going to import the cluster API. It provides us with the RPC, the endpoint. And from wallets, we're going to import the Phantom wallet adapter. And from React UI, we're going to import the wallet button, connect wallet button, and wallet model provider. It provides us with the a pop-up for connecting with the wallet. We'll be able to select a wallet from that pop-up. That one. And next, from wallet adapter React, we're going to import the connection provider. We'll be able to connect with the endpoint using this. And then we'll need a wallet provider. Done. From the wallet adapter base, we're going to import the wallet adapter network. So this provides us with the different type of networks, the devnet, the testnet, or the mainnet. This provides. Now we have the imports ready. Now here what I'm going to do is I'll select the network which I'm going to use. I'm going to use the devnet. So wallet adapter network dot devnet. Done. Next we need the endpoint, right? So endpoint will be provided by cluster API which we have imported from the Solana Web3.js. I'll use a memo and I'll import the cluster API, and the network is devnet. I'll add dependency as network. Done. Next, wallets, we're going to use Phantom wallet. So again, I'll use a memo and we'll create a new wallet. We need to pass the array of wallets. We are only using one wallet, so I'll just pass Phantom wallet and I'll leave dependencies as empty for now. Done. So we have the endpoint ready, we have the wallets ready. So endpoint, let's wrap it. So the connection provider first. Endpoint is which we got here. Done. We have provided the endpoint. Okay, let me cut this for now. Next we have to give the wallet provider. We're going to use the Phantom wallet. So here's the list of wallets. And next I'll pass one more thing, that is auto connect equals to true. If we say auto connect equal to true, let us say we have connected our application to the wallet for the first time, and for the second time it will not ask us to approve. Okay, it will stay connected. That's why I'm saying it as auto connected. Next, now I'm going to use a wallet model provider. So what it does is it'll provide us with a pop-up to select a different wallet. Right now we'll use Phantom wallet, but this model will show us multiple wallets. We can select any one of the wallet from that. Done. Now we have the wallet model provider. Now here I will place a button, wallet multi button. So using this button, we'll be able to connect with the wallet. So we'll not create a special component for button. Uh, we'll take it from the already available package. So we'll be using that. Once we click on that button, we'll be seeing a wallet model. We'll select the wallet and we'll be connected. Let us see the application. Okay, let me refresh. Okay, it's empty right now. Let us see the, okay, done. So now, okay, we need to wrap, right? So we have created the wallet context provider. We haven't wrapped it, that's why it is empty. So now what shall we do? Yeah, here in the layout.tsx file, I'll use this wallet context provider, and here we need to pass the child, right? Okay, I'll keep the child here in this wallet model product. We need to change this a little bit, but just for now I'll keep it like that. We'll see whether we'll be able to see the wallet connection button. Done. Okay, I'll just say notes the app. Done. Now let us see. Okay, let me refresh. Okay, let's do one thing. Let's stop the application. Let's start it again because we've installed, we have imported some packages. Let's start it fresh. Okay, now we can see it shows some error. It's a hydration error. We can ignore that. Now we can see we'll change the UI, but yeah, if you can see we have a button that is to disconnect. Okay, if I add the UI, then we'll be able to see. Okay, I'll add that. So here we are importing the already available UI, right? But we are missing the styling, which is why we are seeing it in this way. Let's add some styling. So for styling, we already have it from the Solana Wallet Adapter React UI. So I'll just import their CSS. Just import their CSS at Solana Wallet Adapter React UI slash styles.css. Then we should see it nicely. So you can see a button. This is what I kept in the page.tsx file. It's a button. We click on that because I've already connected. I can see my address. Okay, I'll disconnect it. Now if you see, if I refresh, you can just see select wallet. If I click on that, we'll see this model. This is model which we provided here, this wallet model provider. Okay, so in this right now we're going to use Phantom wallet. So I'll click on Phantom. Done, we're connected. And if I click on this, we can copy the address, we can change the wallet, or even we can disconnect the wallet also. So this part we are not coding that, we are already using the existing component. Okay, done. Now we are done with the wallet connection. We are done with the wallet connection. Let us build the header for our application. Okay, I'll split the screen. Okay, Done. Now here I'll add a header for our application. What I'm gonna do is, for now okay, here I'll add a header. We'll take a div and I'll give it a full height. This is for the entire screen, so I'll give it a min height of screen. So it'll take the screen of height. Let us provide some background color. Take BG gray 100. Done. Now we can see it is taking the entire screen space. Okay, we'll fix this with gray 100. Done. Now let us remove this from here and add it in this div. Okay, now we can see it here. Okay, now we need to still change something. So what I'm gonna do is, I'll add a header in this. I'll take a div, I'll add a heading, I'll call it as notes dap. Done. Now I'll remove this from here, the child. I'll wrap that within a main element. Done. Now what else we have to do? We need to style this. So we'll style this text to Excel, font bold, text gray 800. Let us see. Okay, we can see notes dap. Done. Now here, okay, I'll cut this from this place. Okay, I'll add it here. So let's do one thing. Here it will be the heading, and here let's place the valid button. Let's make it flex, justify between items center. Done. So we have the heading, we have the button. Now let's style the header again. Here let's take some background. I'll take a white background. Okay, so you can see a subtle difference here. We'll take a white background. Let us also add some shadow, small shadow, not big. Just take a little shadow, so we can see a small shadow. Let's provide some padding too. I'll take px5. Okay, that's cool. And py5. Okay, this is yeah, this is nice. Now let us take a border at bottom, so we can see a small border. Done. Okay, I'll color it, then we'll be able to see. Take gray 200. Okay, a small border we can see. Done. Now we have the header of our application ready. So here is our child. Okay, we cannot see that. We need to change the color. We'll change that. Okay, let us add some padding to the child also. Okay, I'll add E5. So you can see we got some padding for this child. Done. So we are done with the header and the wallet connection. Cool. Now let us get into the main part. So here we are gonna write the logic for creating the nodes and displaying the nodes, updating the nodes and all. Okay, cool. Now here we have the home component ready. So previously I've said that we'll be using the ideal file, right? We'll be using the ideal. I've already downloaded it on my system. So let's copy this ideal and I'll define as a constant. I'll try to code everything in single file to make it easy for beginners. Okay, we have our ideal, so just assign it to a variable and keep it. I'll say why we are going to use it, and we'll also need a program ID for us. Our program ID. So to create program ID, we would need our public key. So yeah, we imported public key from the Solana Web3.js. Here we need to pass our actual public key, which we can get from the Solana Playground. So I'll go to the Solana Playground. So here, okay. So this is the public key of our program. So I'll copy it, paste it, done. So we got our program ID ready. Next, now here let us create a connection. Okay, we'll import use connection. So use connection is from validator.react. We'll take the connection from that. We'll also use the wallet. So in order to use the wallet, we'll take use wallet, done, save it. Okay, it says some, okay. Let's make this also a client-side component, done. Okay. Error is gone. This is also a client-side component because there's a lot of client-side code which we are gonna write. Now we have a connection. So this will provide us the connection with the Solana Devnet, and use wallet will be able to use the wallet context like the pub key of our wallet, the current wallet, this one, current wallet pub key and the address and all. Done. Now next, I'm gonna define a function. I'm gonna define a function called get program. Okay, it's a utility function which we'll use. So we have written our program and we have deployed it on the Solana blockchain, right? Now in the front end, we need to get that program because we are gonna interact with that program, right? So now here we need a provider. We're going to use the anchor provider. We'll get that from the project crm/anchor. We've already installed that. So what this does is it'll create a provider for us. It'll take the connection and the wallet, and options I'll leave them as empty. It is showing some type error. For now I'm going to use any types. Okay, I'll make it any so that we can make it fast. Okay, now what it does, it takes connection and wallet. Now I'll return the program. So new program, will import it from project crm anchor. Now here you can see it takes the ideal, the program ID and the provider. So the ideal is which we have here. So we need to provide the type. So I'll just take any type. Now again the program ID which we got from here, and the provider, we just created it here. So now in order to get the program, we need the wallet, right? Let us say user is not connected. Then we should not return the provider. So we should not return the program. So that we need to check whether the wallet is connected. So if we have this wallet.public key and wallet.sign transaction, okay, sign transaction, okay. If we don't have any of this, we will not return the program. Instead, we'll just return null. Okay, if user wallet is connected and if it is ready to do the transaction, we'll have the public key and we'll also have the sign transaction method ready to use. If we don't have any of this, we will not get the program. Instead, we'll just return null. Now this is how we get the program. So this is the basic layout. So now what we have to do is we have to fetch the nodes. We need one function to fetch the nodes, to load the nodes, and we need one function to create the node, and we need one function to update the node, and one function to delete the node. Okay, first let us write the function for loading the nodes. Okay, so now let us see how we are going to use this program to load the nodes. Okay, So I'll define a function load nodes. Okay, let us make it async because we're gonna call the program we have deployed. Async, done. Now again, here also let us say the user wallet is not connected. So if wallet is not connected, will not have the pub key. I'll just return, done. Will not load the nodes. Okay, now here I'll take a try catch block. Error. I'll take a try catch block. Now I will call the program get program. I'll get my program. If not, I'll do nothing. I'll just return wallet is not connected. Anyhow, we have some conditions but some additional checks. Okay, now we have our program ready. Now we need to get all the nodes. So to get that, what I'll do is const nodes equals to await program dot account. So yesterday we have created the nodes, right? In the previous video we have created nodes. If I open this, you see we have created the nodes, right? Created nodes, and in that the account which we are going to create is a note account, right? So here this is a program derived account. So I'll say program dot account dot note. Then we'll get all the accounts that are related to the note. Okay, note dot I'll say all. What it does is it'll return all the accounts. Let's say there is one user, he created 3 nodes. So when we call this program dot account dot note dot all, it will return 3 nodes. Let us say we have 2 users, each one have created 3 nodes, then total 6 nodes. It will return 6 nodes because we are storing note as a program derived account. So when we call program dot account dot note, we will be able to interact with all the nodes or all the accounts related to the nodes created on the Solana blockchain. Okay, now when I say all, it'll return all the nodes. Okay, irrespective of the author, it'll return all authors nodes. Okay, now we don't want all author nodes, right? So what we have to do is we need to filter. We only need this valid users nodes, the current valid users nodes. So we need to add some filter. So here for that we are going to use memory comparison filter. So how this is going to store is, we see this will be converted to bytes format, and it will be stored. If you see in this, we have the first field as author. It means we'll be having author public key in bytes format stored in the account. So here the filter which I'm going to apply is, say, offset 8. Why offset 8 means, first, for storing this account, we'll be storing the account discriminator. Which we have discussed earlier. That is account, the type of the account, that is note, followed by the data of the account, which contains the author and the title, content, and so on. Okay, so here 8 is for the offset. So we'll start off reading from here. And for each and every node that we store, the starting field will be of the author public key. So here what we'll say is filter this bytes valid dot pub key, the current user pub key dot to is, yeah, now we will get the bytes. So here the data is stored in bytes format, Now we'll filter this particular author. Okay, it'll go through all the accounts of all the authors. We'll just filter this particular author using the starting bytes. We'll ignore this. We'll start off from the ninth byte. Offset is 8, right? So we'll leave this. We'll start from here. We'll check. We'll check for this bytes, the author pub key account bytes. Okay. Then we'll be able to get all the nodes that are created by this author. So this is the memory comparison filter. Okay. We are directly checking the bytes. The account data is stored as bytes, right? So we'll directly compare the bytes. Then we'll filter the data. So now we got the data. We'll store in a state. So for that, I'll create a state. Here I'll create a state. Nodes set nodes. Oh, state. Initially it will be empty and type its array. So I'll just take in any. Will import useState. Done. Here I'll say set nodes of nodes. We just got the nodes and we've added it to the state. Now we'll add something, that is whenever we call this load nodes, it'll take some time, right? So let's add a loader. Let's take a loader. I'll say loading, set loading state false. So here initially I'll set it as set loading true. After this call we need to make set loading as false. Set loading as false. Done. Set loading false. Now let us catch the error. I'll just console.log error loading nodes and put in the error. Done. We can do one thing. I'll take one more state to store the error message. Take message, set message, error message or success message, whatever it is. We'll store that in this state. It's of type string. So here if I got the nodes, I'll set the message as empty if I successfully loaded the nodes. If not, set message error loading the nodes. Error loading the nodes. Done. Cool. Now we have created the function to load the nodes. Okay. Now let us create a function for create node, a handler function. Okay. Now, okay, I'll create a function create node. Again, it is async. Done. So what it takes is, it takes the title, it takes the content. So I'll define two states. Okay, I'll give a space. Title, set title state. Done. Const content set content state empty. I took one state for title and one state for content. So here okay, we'll define the forms for setting the title and content, but whenever we call the create node, first thing we need to do is we need to check whether the title and content are available. So I'll check title dot trim. If it is not there, if not title dot trim or not content dot trim, then we will set the message, please fill the title and content, and return. Will not do anything, we'll just return. Now let us say the title length is more than 100 because the constraint is 100. If it is more than 100, then set a message title too long. We'll say max length 100 characters. Done. Again, I'll return. And same for content dot length. If it is greater than 1000 characters, we'll set a message content too long, max length 1000 characters. Max length 1000 characters. Cool. And we'll return. Okay, we are done with the validation, and next what we have to do is we have to call the actual program, the create node. Okay, so here again I'll take try catch block, error, done. Okay, I'll finish this catch block. Console.log error creating node, it's logged error, and here I'll set the message error creating node. Done. Now let's also take a loader for this, for create node. We already have a loader for loading the nodes. Okay, let's use the same thing for now. Let's see if we can use the same thing. Okay, I'll use the same loader, set loading true, and at the end I'll set loading to false. Done. Now let's write the main logic. Again I'll get my program, get program. If we don't have the program, we'll just do nothing, return. Now what we'll do is we need to derive the address for our nodes, right? Earlier we were discussing, like we were creating the node address from the seeds, right? The same thing we have to do. User will not do that. We need to handle that in the logic. So what I'm going to do is I'll create a function called get node address. It takes the title, and also the pub key of the author. Okay, so here I'll define it here. I'll say const get node address. It takes the title, type is string, and we have the pub key available in the wallet. Right now here again I'll just check this. I'll copy this again, paste it. Okay. Done. Now here we need to create that, right? We need to create the node address. So for that we are going to use public key dot find program address sync. What it takes is the seeds which are provided yesterday, we need to provide them here. It takes an array that is for node. We need to convert this into bytes. So I'll call buffer.from. Buffer.from will get the bytes. Next valid.pubkey. The next one is author pubkey, right? Author address to buffer. Then the next one is title. Buffer.from title. Now we just got the new address. We just got the new address, and it also take the program ID. So it'll create the address using the seeds for this particular program. Done. Let's assign it to a variable. So what it returns, let's see. It returns two things, public key and number. Okay, so we only need that public key, that is the new address which we got. So I'll take node address. I'll just take the first one. I'll just take, it returns an array of two elements. I'll just take the first element, that is the public key. Done. We got the node address, and I'll return that node address. Done. And let's go back to this. Here we'll get the node address. Now we need to make use of that node address and create the nodes. here we got the node address. Okay, we don't need this await. Done. If the node address is not generated, we'll just return. Okay, I'll show you something here. Where is that? Okay, node here. If you see, it generates a valid program address must follow the ED25519 curve. This function iterates nonce until it finds one that when combined with the seeds result in a valid program address. So it iterates through a sequence of values, then it'll get the valid public key. Okay, we were discussing earlier, right? Next, yeah, here if we don't get the node address, we'll just return, we'll do nothing. Now here we need to create the node. So for that, I'll say await. We're going to use program dot. We have some methods available. Program dot methods dot create node. We are going to use the create node. Here we are not getting suggestions because I kept the types as any. Okay, we will pass the content and title. We have discussed it earlier, right? Create node takes title and content, and then we need to provide the accounts. We need to provide the accounts. For node, we have created an account address, right? A public key, and the author is going to be the current valid, that is valid dot public key. Done. Since this is going to create something, we need to provide the system program also. System program, we have discussed this earlier. System program. Okay, to get that system program dot program ID. Done. Now we need to call this RPC method. So what it does is it'll call the RPC method and it'll create the nodes for us. Cool. Now let us say we have successfully completed this step. Let us set our message. Set message node created successfully. Node created successfully. And we'll set loading. Okay, anyhow we'll set loading to false here. Let us set the title to empty and the content to empty. Done. And once we have created a new node, we'll immediately call load nodes because we need to update the nodes that we show, right? So I'll immediately call load nodes. So it'll call the nodes method, then it'll take that and set in the node state. Okay, it gets updated automatically once we create a node. Done. This is for creating a node. Now let us write for updating a node. Again, I'll create a method update node. Okay, async. It'll take node. Here update will take the node. Here notice the entire data of a node. Consider the entire data of a node. Okay, I'm taking it as any type. Okay, now again, so for updating node, we want the user to make change, right? We want the user to change the node which he wanted to change. So in the UI we'll create a form. Once he click on update or edit, we'll show him a input box, then he can edit whatever he want. So for that I'll take one more state, same title and content, but for editing. Edit title, set edit title. Okay, next edit content and set edit content. I'm going to use those states for update. Okay, I'm going to use those states. So now again here the validations. If the edit content dot trim, if it is not provided, I'll set a message and return content cannot be empty, and I'll return. Done. Okay, yeah, and return. Cool. Now the next condition is we need to check the length. If edit content dot length is greater than 1000 characters, I'll copy this. If it is greater than 1000 characters, what's the error? Edit content dot length, it is greater than 1000. Oh, not okay. If it is greater than 1000, then we'll set the error and return. We'll do nothing. Okay. Now we are done with the validations. Next, try catch block. The main logic. Take the error. Let's set. Okay, I'll console.log. Error updating note, and let's log the error. And then we'll set the message. Set message error updating note. Done. So here before this we'll set loading, set loading to true. Here we'll set loading to false. Done. Now let's write the main logic. Again here we'll get the program. Okay, I'll simply copy this. Okay, where is that? Yeah, this. I'll get the program. We'll take this. We even need this one also. I'll take this. Done. So here in the update node, we'll take the program. If not, we'll just return. Again, we need to get the node address right. So how are we deriving the node address? Using the title. Since this is the node which we are going to update, we'll take the node which will update. It'll take the node, and from that we'll take node.account.title. Okay, node.account.title. You'll get to know why account, because here once we get the nodes, we'll get in this format. Okay, that's why we'll take it. Now we have the node address. If not, we'll return. Now let us call the method program dot methods dot update node. It takes content because we are only allowing to edit the content, and accounts we need to provide. The account is node address, and author is going to be the current user. It's public key. Done. And then rpc done. So now we have created a method to update. So here if we successfully update our nodes, let's set the message node updated successfully. Done. And we took two states right for editing, so we'll also set them as empty. Set editing content empty, set editing title empty. Cool. Now once we updated, let's immediately fetch the latest nodes. Await load nodes. So this is a handy method we can call whenever we make change. Cool. Now we have written our update node function. Then next, delete node. Delete node. It will also take node, and it's async method. Async will take node. Will take type as any. Now here again set loading to true initially, and the try catch errors console.log error deleting the note, error deleting the note. Let's log the error. and here let's also set the message error deleting the note. Cool. At the end we'll set loading to false. Done. Now again here we need to get the program. I'll copy this program. I'll do one thing, I'll just copy completely this one from the update note. I'll paste it here. So we got the program, we got the node address. We'll take which node we are going to delete and the title of that node. We get the address. Done. Now the methods for this method is delete node, and here no need to pass any content. Accounts, node address, author is the current, valid public key, and call dot rpc. Successfully completed. Set the message node deleted successfully. Cool. And once deleted, let's load the nodes again. Done. We have wrote the delete node function. So we are almost done with the main logic. Okay. So here while writing the methods, you can see. Okay, let's go with the create node. Here we see they're saying create node, right? Program dot methods dot create node. That one we'll get from here. Create node, the instructions. Okay, that's why we use this ideal. Okay, cool. Now we've created the methods. Now let us start the UI part. Let us start the UI part. Here what I'll do is, let's switch to the UI. Now here, if user gets connected with a wallet and he opens the application, we need to load the nodes. So I'll take a use effect. I'll add a wallet dot connected as dependency. If the user's wallet is connected, then we'll call load nodes. Okay, we'll call load nodes. Done. Next, let us say the user is not connected. The wallet is not connected. Wallet is not connected. In the UI, we will show to the user that wallet not connected. Please connect your wallet. Okay, let's style it text gray 700. Here my wallet is connected, that's why. Okay, I'll color this text gray 700. Now if I disconnect my wallet, so you can see wallet not connected, please connect your wallet, and if I connect, you can see this. Done. Now what we'll do is we'll try to display the nodes that are loaded. Okay, so we have a state, right? We have a state for the nodes. So I'll create a div. In this, first I'll check if a nodes is present. If nodes dot map, then if you have, we'll take the node index and we will render. Okay, here the type is going to be any. So here as of now I'll json.stringify node. Done. So you can see some nodes here because previously I've created a node from my account on this Solana program. So that's why we can see a node already. Okay, so if you see the pub key, the author, the content, the title, and created it and last updated it, we are seeing the object addresses. I think we'll fix it. Okay, now we have just loaded them. Now the next thing we need is we need to create a form where the user can fill in the title, content, and he can create a note. So now let's do that. Okay, I'll create a section for that. So let's name it create new note. Okay, let's take text to Excel. Okay, I'll comment this for now. Text to Excel, and let's add some margin at bottom. Done. And for this also, let's add some margin. Cool. Now here, let's show the two fields, input for title and input for content. I'll take a div. I'll add some margin at bottom for this one also. And in this, now two fields. Okay, this one. Take a label. This is for title. Text small title. Okay, I'll add an input field of type text. Done. So yeah, we can see that field. I want the input field to be below the title, so let's make the title as block element. Done. We can see. Let's make it a little bit better. Font medium. Okay, no change. Cool. Font bold. No, let it be medium. And let's give a text. Okay, already we have gray, right? Done. Now the text type is text. Name, I'll give it as a title, unit of ID, and value is gonna be title. We already have a state for title and content, right? Now on change, so here it will take E. We will get the E, and set title E dot target dot value. Done. Okay, now let's type. Okay, we can see that. Let's also add some border to this input field. Border. Okay, I'll take border 2. Border gray 300. Okay, I'll make it rounded. Done. Let's add some padding. Okay, now let's type in. Yeah, it's fine. And let's make the width full. Yeah, now it takes full width. Cool. Now I'll copy this same for content. Okay, before that, let's do one thing. Here, yeah, here. Let us also show the length. Okay, we are only allowed to have 100 characters, right? So I'll show title dot length by 100. So whenever we type, you can see the length left over. Okay, now, and what else? Yeah, I think that's it. Here it should be content, and length is 1000 maximum, and content here should be set content, name it as content, value is content, and yeah, let us make it a text area. Sorry, text area, unit of type, and we can directly provide the max length here of 1000. Done. Let us take few more rows. I'll make 5. Yeah, let's also add a placeholder for both of this. Title here, and content here. Cool. We got two fields. Yeah, let us add a button to submit. Okay, here I'll add a button. I'll say create. Okay, let's take it conditionally. We have a loading state, right? Whenever we create a node, we have a loading state. So if it is loading, then we'll show creating node, else we'll show create node. Okay, and let's style the button. I'll take full width. Done. I'll give some background. Blue 500. Okay, let's round it. Okay, let's change the color. Text white. Done. And font bold. Okay. Okay, I'll style it later. Let's add some padding. Okay, for X let's take 4 and for Y let's take 2. Okay, done. We got our create button and we need to disable it, right? It should be disabled when it is loading, or even we don't have title. Let's say we don't have title in that case also, and we don't have content. We should disable the button. Okay, we can even add it for disabled. You can say bg blue something like this. Okay, let's increase. Okay, yeah, it's disabled. We can even change the cursor pointer. Disabled, cursor not allowed. Done. Okay, cool. Let's say we have something, then we are enabling, right? Now let us uncomment this. We'll style it later on, but for now we have one node, right? Now let us try to create a node. We have completed a form, created a form. Okay, I'll give it a title, node 2. This is node 2 from the front-end app. Okay, let me make it full screen. Oh, it's better to view it like that. Okay, I'll click it here. Okay. Oh, okay. We need to add on click, right? On click, we have to call the create node. So once we call this function, it will take the title and content from the existing state and it will call the method. So now I'll click here. It says it's loading. So now, okay, I have to approve the transaction. I'll confirm it. It's loading. So now we can see a new node got created. Node 2. Okay, I'll make it full screen. Node 2, and the content is this is node 2 from frontend app, right? Second node got created. Done. Now let us make the UI for this nodes better, and then we'll add the update and delete options. Okay, now here for this, for each one, first we'll show the title. It should be node.account.title. Okay, node.account.title. We got the title. Let us make it h3 and text 3xl. Sorry, not 3xl, let it be xl. Okay, font bold. Nice. Now let's show the content of that. Take a paragraph. Node dot account dot content. We're showing the content. Let me add some space. Space y4. Okay. Okay, let's add it at the bottom. 6. Yeah, it's fine now. Okay, I'll provide the key. Okay, let's take the node dot account dot author as the key. We'll get the pub key. So I'm taking it. So no need of this. Done. Now this is the content. Let us also show the created it. So created it, we are storing it as a unique timestamp, right? So for that we'll do one thing. So we'll say new date. We'll take node dot account dot created it dot to number. Okay. Okay. Yeah, to number dot to local string. Now we can see that. Okay. Created it, and same for last updated also. Sorry, last updated. You can see last updated. Let us style them. Border of 1 pixel. Okay, I'll give border to entire note for this. Borders to border gray. This. Okay, rounded large and some padding. Cool. Now it looks nice. Let me make it 200. 300 is better. Yeah, we're showing the nodes. Let us make it smaller. Okay, class text sm. Font. Okay, let me give it a lighter color. 500. I think this is better, and yeah, I think this is enough for now. Now let us show two buttons. One is to update and one is to delete. Okay, I'll show the buttons at the bottom here. Button, update, delete. Okay, we'll make it flex between. Done. Let us style the buttons. Oh, okay. Yeah, let us style the buttons. I'll take a padding of 2 pixel, and let's take a. Okay, I'll style them separately. One with a green color, PG green. Okay, and rounded. Done. And for this, BG red 400 and rounded large. Done. We got two buttons. Okay, let me add some padding at the margin at the top. MT6. Done. We'll change the text color in this? Text white. Okay, then we need to increase this intensity. This one also 600. Yeah, I think this is fine. Okay, now okay, I'll do one thing. I'll place them side by side. Gap of 4. And okay, no need. I'll just give some gap. Done. Now let us add on click, that is update note, and for this on click delete note and disable when it is, we are using the same loading state for everything for now. Okay, loading. And if this is for update note, right? If we don't have edit title dot trim, if we don't have anything in edit title, we'll not do anything. And if you don't have anything in edit content, not do anything, right? And here also we'll disable it when it's loading. Done. Now once we click on update, we need to show an input field to update, right? First let's test the delete, then we'll go with the update. Okay, here we can add something. If disabled bg red, oh sorry, it should not be red, it should be green. Okay, I'll just make the cursor not allowed. This should be enough. And here also cursor not allowed. Okay, for update okay, on clicking on update, okay, I missed it. So here it should be edit. Let's make it edit. So on clicking on edit, then we need to show the update button, so we'll do that. For now I'll remove this on click. Okay. When we click on this edit button, then we should show a text field with this, and then we should show the update button. Okay, we'll do that. Now here let's test the delete first. Okay, I'll click on delete. There is some issue. Okay, same key. Okay, got it. Here we are using author as the key, right? Where is that? Yeah, here. Author is same, right? So I'll just take index as of now. Or we can use title. Okay, let's use the title. Title is unique, right, for us. Yeah, now we can see. Okay, I'll reload it. It got rendered 2 times because we were changing the keys, right? Now I click on delete. Okay, we have attached a delete note. Okay, we'll set loading to true. Okay, it should be fine. Okay, I'll click on delete again. Let us check the console if we see some errors. Okay, can't read title. Where is that? Yeah, we need to do one more thing. So that is, so here whenever we click on delete, we should not delete it directly, because let us go through this delete function. If you see this, we are passing a note, right? We are passing a note to the delete. Okay, here we need to pass delete note and the current note we'll get from here. Okay, Now once we call this, we'll get the note, we can get the title. Yeah, it should be fine now. Let's test it. It's loading here, so it's fine. We'll show a loader again. So now if you see, when I click on delete, okay, you click quickly make it loading, deleting is deleting, else delete, right? Now okay, yeah, can reload it again. Yeah, so now if I click on delete, it says deleting. So we are seeing it to the two buttons, but it's fine, we'll fix it. So now when I click on delete, you can see it's asking to confirm the transaction, but if you see, it is showing plus some Solana, some tokens. So as we discussed earlier, whenever we delete, we get back the rent which we have paid extra, right? So we'll get back the Solana. Now once I confirm this, it should be deleted. So node 2 got deleted. Cool. Now here the next thing is update, right? So now whenever I click on this edit button, we need to show a text box with update button. Okay, so let's do that. What I'll do is I'll take a state, and whenever user clicks on the edit, then in that I'll store the notes that user is editing and the content that the user is editing. Okay, so here we have for, okay, we don't need for edit title, I'll remove it. I'll take a state called edit note, set edit note. This state will contain the note that user is going to edit. User is going to edit. Initially it will be null, we will not have anything, and type is going to be any. Okay. Okay, edit title is not defined. Okay, here it is. No need of this. Okay, we are not going to edit the title, right? And here also. Cool. Now so whenever I click on this edit button, what I'll do is I'll create a state and I'll set this particular note in that state. Okay, and I'll render that for the updation. So here, when our user clicks on this, on click, I'll see set edit note to this particular note which we get here. Done. Now once we set that, once we click on this button here, we should show the update form. I'll take a div here. Here, whenever we click on edit, we'll set the note, right? Whenever we have the edit note, if we have the edit note set, then we'll render this, else will not render. Okay, so in this, okay, let me add some space. Here we'll show a text area, update content, and the value is going to be the edit content. So initially we need to set the value as edit content. So whenever user clicks on this, we need to do this one also. We need to set the edit note, and we need to set the edit content as note dot con dot content. We'll prefill this content, prefill. Okay, now here edit content, then we should be able to see the content. Okay, again, let's take the same style from this one. We should remove some. Remove this. And remove this. Yeah, here on change, it should be set edit content. Now let us test it. When we click on this, we'll set the node, we'll set the pre-filled content, and we'll render it here. We'll click it. Okay. Okay, edit. Okay. We should not have this condition. Now, so if I click on this, you can see, right here I'll also show a button. I'll call it, okay, I'll copy the same styles. What's the issue? Okay, yeah. Here I'll take a blue color and I'll make it as conform. Okay, I'll just call it as update, simply update. Okay, now on clicking this, we need to call the update node. Let's go to the update node. It is taking the node, right? So update node, it takes the node, the current node, right? The update node, once we click on the edit, then we'll show the user with the text area which is pre-filled. Then we'll also show the update button where the user can edit the data and then he can update it, right? Now next, here let's test it. We'll call update node and disable it when loading. So here when I click on edit, we'll give a cancel button to this. So what we'll do is, here if we have edit node, then we'll give cancel, or else edit, we have cancel button. Okay, here if edit node is already opened, then we should cancel it, right? It means set edit node to null, else we'll edit it. If I click on it, it gets cancelled. Click on it, edit. Now next, okay, here we wrote, let's update the content. Note 1 content updated. Again I'll click on update. Oh, it's showing deleting here, because we are using the same loading state, so don't get confused with that. Okay, so now it says no balance changes found, please proceed. Okay, so now I'll confirm. So now you can see the note 1 content is updated. We want this to be closed, right? We want this to be closed. So what we can do is, in the update function here, in this, after we set the edit content to null, we'll also set edit node to null. Once we set this, we'll get back to the same, right? Now let us test it completely. We have almost finished it. Okay, let me create one more node. I'll call it as node 2. This is node 2 created from front end. Create. Don't get confused with this one. Okay. Confirm. It's loading. Node 2 got created. Right. Now let's edit this. Created from front end and later updated from front end. I'll click on update. Now it should get updated and it should get closed. Click on update. We need to add loading states. We'll add that. Confirm. Now you can see it is updated. So now let's do one thing. We are using the common loading state for everything, right? So let's use different loading states for each one. So here, so let it be for creating node. Let's use the same. And here I'll make one for deleting a node. Okay, delete loading, comma set delete loading. Okay, state false. Done. For update we need, right? Update loading, set update loading, capital. Done. Delete update. And okay, let this be for the loading of data, and we'll create one for creating a node also. So create loading, create loading. It should be a here, a here, a here. Now we have different states, loading states. We even need to show the error message also. We'll show that. Here I'll take this. Where is my create node? Yeah, here I'll use set create loading and set create loading. Here should be set update loading, set update loading, set delete loading, set delete loading. Done. Now we have different states for each one, and for content also let's show a loader. We are not showing a loader, I think. So here, where is that? Okay, let's take this, wrap in a div. Your notes, text to Excel should be fine. Your notes. Okay, and paste it. Now we can see our notes and margin bottom 6 pixel. Cool. So now here let us show loading here. Okay, cut this. So if loading, now this loading state is only for fetching the data. Okay, if it is loading, we'll say loading your notes. Okay, else we'll show the notes. Now let's refresh. If you can see that, loading your notes. Done. Your notes. Okay, next. Let's try creating node 3. This is node 3. Create. Okay, for the buttons also we need to change. I'll cancel this. Where is the create button? Create button should be here, I think. Yeah, here it should be. Create loading, and here also create loading. I'll use the same state, and yeah, this for create. We need to make the same for update. Where is the update button? Yeah, this is the update button. So it should be update loading, and here I'll say if update is loading, updating, else update. Done. And next we will also disable this edit button when update is loading. Okay. Next, for the delete button, it should be delete loading, and here also it should be delete loading. Then now it should be perfect. Create note, it's loading. We got the valid prompt, confirm, it's loading, done. We got our node 3, right? Now let us try to edit this node 2. Okay, let's edit that. This is node 2 from frontend updated later. Update, say update to update. So here if you see, no balance changes found. Why? Because we are just updating it. Whenever we have created a node, the space got allocated. 1000 characters for the content, 100 characters for the title, and all the fields are allocated. The space is allocated. There is no change in space. That's why it says no balance changes found. Okay. Now confirm that. So update loading. So you can see update to, it got reflected. Now let's try to delete this. Delete. Oh, now one more issue. If you see, it is showing delete for all the 3 buttons, right? So for this we can do one thing. So whenever we click on this, we can store the title of the node which we are deleting, and we'll only show loading for that one. Let's do that first. So here, whenever I click on delete, I'll go to this here. So here along with this, what I'll say, okay, I'll take a state const deleting note, deleting note. Okay, I'll call it as deleting note title. Okay, deleting note title empty. Okay, set, done. Yeah. Now what I'll do is, whenever I click on delete button, I will store the title of that note, and for showing the loader, will show the loading only for the selected one. Okay, I'll take this. So here, where is my delete? Here. Yeah. Here I'll set node dot account dot title. Set the title, and here for loading, it is loading, and this node dot account dot title is same as the one we are storing in this one. Okay, and it should be same here also. Okay, it should be, and copy this. Let's test it now. So now we can see only we are showing it for one. Once we did this, once it got deleted, we need to reset this one, right? So I'll go to this, here I'll reset that to empty. Done. Now let us test it. Delete. Since we're deleting, we'll get back some Solana. Confirm. It got deleted, right? So this is for the front end, right? We have created a program, we have created a front end with valid integration, we have tested, create, update, delete, and we are rendering the nodes, right? Now let us deploy it on Vercel. Let us check if we have any lint issues. npm run lint. Okay, we have several lint issues. Let's resolve them. Unused variables and okay, any. So we need to ignore this one. Let's ignore that. Can take this. ESLint disable. Next line. Okay, done. And message. Okay, we thought of showing message, but for now we are not using it. So I'll just log it somewhere so that we can avoid the error. Okay, I'll remove it. Oh, we have it in many places. It's okay, I'll delete all of them. I've deleted all of them, and yeah, we have few more. Yeah, here, done. Next, okay, I'll run the lint again. Okay, here. So I'll copy this same. I'll place it wherever we have any. So here and here. Okay, in this 100, line number 100. Okay, it should be smallest. Okay, and where else we have any? Okay, here and here, here. Okay, here it should be like this. Next, done. I think we have cleared the lint issues. Okay, one more here. Done. We're ignoring the lint issues. No lint issues found. Now I'll push it again. Now hit push. Done. I have published the changes that I have made and updated my Git repository. Now let's go to Vercel. Go to vercel.com. If you don't have an account, just create an account. Once created, connect your GitHub account so that you can import the projects directly. So we can see the nodes, the app, the repo. I click on import. Done. Now I'll name it as nodes tab and I'll click on deploy. Okay, the name already exists. So I'll name it as Solana nodes tab Solana. Yeah, now it is deploying. It'll take some time. Yeah, now we can see that the project got deployed. Now I'll click here. So you can see nodes dap solana.vercel.app. It's the link for our application. I click on select wallet, Anthem, connect. It shows the nodes because we have already created some just before, right? So we have 1 and node 3. Now let's create one more node. We'll say node 4 content from Vercel app. Click on create node, confirm, done. So we have created our front end and we have deployed it on Vercel, and our Solana program is running on the Solana Devnet. So This is a full stack Web3 application which we have built. Thanks for watching this video till end. If you like this video, consider hitting the like button, subscribe to the channel and share with your friends. Thanks once again.